Welcome to Pomodoro Joe for Wednesday, February 8th, 2023. Today we're doing LeetCode problem 45, Jump Game 2. This is a medium problem. And the problem statement says, you are given a zero-indexed array of integers, nums, of length n. You are initially positioned at nums 0. Each element nums I represents the maximum length of a forward jump from I. In other words, if you are at nums I, you can jump to any nums at I plus j, where j is 0 less than or equal to j less than or equal to nums at I, and I plus j less than n. What? Return the minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. And then we have some constraints. Okay. All this is saying is you have an array nums. If you're position I in that array, you can jump to I plus the value at nums I. Okay, I think that's pretty straightforward. And we're trying to get to nums at n minus 1. Okay, so with that, we'll put 25 minutes on the Pomodoro timer and get started. So with something like this, we will start with our result and set it to 0. And we will return our result. And let's see, we'll look for any early outs. So that's if the length of our nums is less than 2, we can just return. So let's do that. All right, so we have our early out, we have our result, and now we have to get into the heart of the problem. So for a problem like this, I like to find the components that we have to play with first, and then we can figure out how to build them into an algorithm. So we know we have a position, so I'll call that pause, and we start at 0. We also know we have a maximum jump that we can get to. I'll call that max jump. And that is going to be our position plus the value at that position. So that's pause plus. Okay, so we have our position and our maximum jump. If our maximum jump is greater than n minus 1, then we can return. Okay, so that kind of gives us a little bit more information. Actually, it looks like it's greater than or equal to. Okay, now what else do we have? Well, somewhere in between our position and our max jump position, there's a best jump position. So I'll just call that best jump. We don't know what that is yet, so I'll set it to 0 to start with. So what defines our best jump? Well, let's see. If we had an array that was something like 2, 1, 1, 1, 1, whatever. Well, from starting position 2, we can jump 1, 2, or we can jump just 1. In that case, it looks like our best jump's going to be jumping to the maximum point. But what if our array looked something like this? Well, then jumping 2 will land us here at 1, and we'll just keep hopping 1 until we reach the end. But if we just jumped 1, we would hit 10, and we can just jump to the end. So our best jump is not necessarily our max jump. That's the first thing to note. Okay, what else do we know about this? Well, what if it was something like this? 3, 2, 2. All right, so if we are at our very first position, we can jump 3. So we can jump 1, 2, 3. If we jump to the one with the highest number, we would jump to this first one, and then we can jump 3. 1, 2, 3, ending up just before the end. But we could jump to 1, 2, 3, this 2, which then gets us to the end a lot faster. So just jumping to the index with the highest number is also not necessarily our best jump. It turns out our best jump is going to be the jump to a position where that position plus its value gives us the greatest number. You can think of it as the place that we jump to is a new position. That's our new base. And the best jump will be a jump to a position that then can jump us to the furthest point. So you kind of have to think one move ahead. It's not just how far can we get in this jump, it's how far can we get in this jump plus our next jump. Okay, so with that out of the way, I think we can start finding our best jump position. So we need some type of loop, and it looks like we need to say, well, maybe we'll start with this if. Instead of saying if the max jump is greater than or equal to length minus 1, let's say while the max jump is less than the length of nums minus 1. So this is, we haven't found our jump that will reach us to the end. And we'll remove that. Okay, so what's next? Well, next we need to say between our position and our max jump position, there is this best jump position. So let's just start moving through all of those possibilities. So for some index I in the range from our position to our max jump position, and we can actually reach the max jump position. So in range, we have to add 1 because range is non-inclusive. All right, so then for every position between our current position and our max jump position, we'll check to see, is this one the best jump position? And then how do we do that? Let's see. Well, so we have to say if our I plus our nums at I. So that's the new position plus the place that it can jump to. If that is greater than our current best jump plus its range, well, then our best jump becomes this new position. Okay, that might be a little confusing. I'll walk through that again. So we're saying for every position between our current position and the maximum point that we can reach on one jump from this position, let's check to see which one of those positions has a further reach, has the furthest jump. So you check that position and how far you can reach from that position against your current best position and how far you can reach from that best position. And if you found a better position, then you replace your best jump with that. Okay, and now if we get outside that loop, we've found our best jump position. This is where we have to do a little bit of our bookkeeping. So now we will update our position to be our best jump position. So we make that jump. And because we made that jump, we need to increment our result by 1. And our max jump also changes. So let's see, the max jump now is going to equal our current position plus the number at that position. Okay, I think that might be it. Let's run that and see how we do. Num is not defined. Nums. Same thing here. Okay, we'll try that one. And we totally fail. Now what went wrong here? Let's see, we made one jump. We are missing our last jump out. So that's the one problem. So we need to return result plus 1. You always have at least one jump. All right, let's see. I'll submit that, why not? Hey, and we pass, and we do pretty well. So with this algorithm, we beat 98.53% of other algorithms for runtime, and we beat 54.9% for memory. I'm pretty pleased with that. Not too bad for your first attempt. Now there are things we can probably do to improve upon this. Let's see. Well, maybe not. I'm looking at this, it doesn't look too bad. We could maybe cache this length, because we do call it twice, but honestly, I don't think that's going to save us much. Yeah, looking over this, I think this is actually pretty darn good. Well then, I guess we're done early. I'm pretty pleased with this one. All right, well, there you have it. That's how we solve LeetCode problem 45, Jump Game 2. Check this one out on your own. There are lots of different ways to solve this one. This is just the first one that I tried, but you could solve this recursively. You could probably solve this with backtracking. I haven't tried it. Yeah, this is just one solution of many solutions. So feel free to try this one on your own. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.